Welcome everybody. This is Dr. Looney, and today we'll be talking about one of my favorite subjects, antiderivatives. Now I know you guys are used to finding the derivatives, one of your favorite things to do in AP Calculus, but guess what? It gets even better now. We're going to take the antiderivative. So give yourself a hand clap because we've almost come to the end. Alright, so remember these terms: position, velocity, and acceleration. So if I take the derivative of position, I get what? Velocity. If I take the derivative of velocity, I'm going to get acceleration. Well, what if I had acceleration? I knew how a particle was accelerating, but I wanted to find the position function. Is it possible to do that? Or could I find the velocity function? Well, guess what, guys? It's possible. We can do it. So if I have velocity, if I want to find the position function, well, since the velocity is the derivative of position, if I want to undo the derivative and get back to position, guess what I do? I take the antiderivative. All right, now that we know how we can use this, let's find out how to take the antiderivative, because we can see how important it is now, right? All right, so let's just say I have f of x is equal to x to the n, and I want to find the antiderivative. And when we're talking about the antiderivative, we use f of x. We're going to use capital X. We're not going to use that lowercase f anymore. We're going to do something basically using inverses, because when we took the derivative, when we had x to the n, if I was to take the derivative, what do I always do with my exponent? I now multiply my exponent, right? And then I reduce it by 1, so I get n minus 1. But when I take the antiderivative, I'm going to now divide by the new exponent. So let's just start here with the antiderivative. You're going to take your new exponent, and instead of reducing it by 1, you're going to add 1 to it. So you're actually going to get x to the n plus 1. And then instead of dividing, instead of multiplying, I'm going to divide by the new exponent. And then I'm going to add a constant to it. And anytime you take the derivative of your antiderivative, you should get the original function. So I will ask you to pause and on your own take the derivative of f of x, capital F of x, and see if you get f of x. And I'll be walking around just to answer any questions that you may have, just to make sure that you do see that the derivative of capital F is going to be f of x. Okay, so now keep in mind, all of this is leading up to problems such that if they give me velocity, I should be able to find the position function. Or if they give me acceleration, I should be able to find the velocity and the position as well. And so that's what we're leading up to. But just today, we're just going to go through some simple problems just to make sure you understand how to take the antiderivative. But our motivation is to be able to go from velocity to position and from acceleration to velocity back to position. So that's really what we're leading up to. All right, so I'm going to start out with this function. Let's just say I want to integrate f of x is equal to 3. So I want to find the antiderivative of 3. Now keep in mind, if I want to find the antiderivative, that means that 3 is the derivative of some function. I just need to know what that function is. Just like the velocity is the derivative of position, if I take the antiderivative, it's going to give me position. So this is really the derivative of some function. I'm going to do the antiderivative to undo something that's already been done. So now I told you that when you take the antiderivative of x to the n power, you get x to the n plus 1 divided by n plus 1 plus c. But if you look here, you don't have x to any power. But you can, not yet, but of course you can rewrite this as 3x to the 0. And so if you want to find your capital F of x, you're going to do what? You're going to add 1 to your exponents and divide by your new exponent. So this is going to be 3x to the 0 plus 1 divided by 0 plus 1 plus c. And once you reduce all that, you just get 3x plus c. Alright, so that was pretty simple, huh? I think we're in good shape so far, so we just got to keep pushing. And we're going to get to the mountaintop. Alright, so let's look at another example, see if we can find the antiderivative of x squared. So remember, if I'm finding the antiderivative, this is the derivative of some function. So I just want to find out what function this is the derivative of. So I'm going to do my quick little trick. I'm going to take my exponent and add 1 to it, divide by the new exponent, then I'm going to add c. Well, that's just going to give me x to the 3 over 3 plus c, or I can write that as 1/3 x to the 3 plus c. I think we got it. Pretty fun, pretty cool, amazing how math works. So I want you to try this example on your own. I want you to find the antiderivative of x to the 4th. So go ahead and pause the video and collaborate with your partners and see what you come up with. Alright, now that we're back, you should have ended up getting 1/5 x to the 5th plus c. Amazing, amazing work. Amazing work. Good work, guys. Alright, so now let's make this just a tad bit interesting. What if we had the square root of x? So now I have the square root of x. So if I have the square root of x and I want to integrate that dx, well, that's going to be equal to what? Well, the square root of x is not written as x to a particular power right now, but can we do that? Of course we can. We can rewrite this as x to the 1/2 power. Alright, so again, we still do what? We add 1 to the exponent to get the antiderivative and divide by the new exponent. And then we're going to add our c. So we get 1/2 plus, I'm going to go ahead and write this as 2 over 2. 1/2 plus 2 over 2 plus c. So that gives me x to the 3/2 over 3/2 plus c. Now when you divide by a fraction, you're really multiplying by the reciprocal. So the answer is going to be 2 over 3 x to the 3/2 plus c. Alright guys, so that's where we're going to end for today. Thank you for listening, and we'll see more on this topic in the future.